let's evaluate the integral from 0 to 3, from 0 to x squared to 9 of x cubed e to the y cubed dy dx. Now normally we like to just start from the inside and start taking the antiderivative. But we know from Calc 2 that e to the y cubed does not have a nice antiderivative, so we can't do it that way. The standard procedure here is to try to reverse the order of integration and then try again. Now, reversing the order of integration means sketching the region and chopping the other way. So what we're going to do is sketch the region first. Remember that this is actually y equals x squared, and this is y equals 9. And so we're going to sketch those first. Y equals x squared looks like this. Y equals 9 looks like this. And remember, the outside limits of integration correspond to how far left you can chop and how far right you can chop when it's the x. So the region we're looking at is this region right in here. Now, we want to chop the other way. Well, what way did they chop, right? They chopped parallel to the y-axis first. We can see that. I'll have to redraw the region in a second, but that's all right. Right? We can see that because they hit y equals x squared first, and then they hit y equals 9 next. We don't want to do that. That gives us an integral we couldn't do. We want to chop the other way. So you want to chop parallel to the x-axis first. So let's draw a region again. Like this. This is still, what is this here? This is the point 3, 9. This is the graph y equals x squared. This is y equals 9. And what we want to do is chop the other way. So instead of chopping south to north, we're going to chop west to east. Go like this. All we really need to know is, well, those 2 points have the same y-coordinate. Let's do that. That's what we did in Calc 2. We can do that here. Go like this. Go like this. So they have the same y-coordinate. So what I need to know is what the x-coordinate is. The x-coordinate when it hits the y-axis is just 0. That's in fact the equation of the y-axis. When it hits the parabola, we know y equals x squared, but we don't want to know what y is. We want to know what x is. So we solve this for x, getting plus or minus the square root y. We know it's only a positive square root y because we're on the right half, so this is square root y. Looks like this. And we start resetting up the integral. Now remember, we don't change the roof. We're not changing the solid, the Play-Doh solid at all. We're just chopping the other way. So the roof is still the same roof. It's still just x cubed e to the y cubed. We're now chopping the other way, so we're going dx dy. Like that. How do I find these limits of integration? They come from the x-coordinates of when I chop. So this is going to be 0. This is going to be square root y. What do I get for the y's? I need to know how low can I chop and still hit the region. Well, I can see that I can chop as low as 0 or as high as 9 and still hit the region. And that gives me the location limits of the chop. So I'm just going to go from 0 to 9. And now I get an integral that hopefully we can do. Now how do we do this? We just, remembering, by the way, that that actually is a function of y. We evaluate it. The 0 to 9 change stays the same. How do I take the antiderivative of x cubed e to the y cubed when I couldn't do it before? Well, when I did before, I had to take the derivative of e to the y cubed where x was constant. This says I want to take the antiderivative of x cubed where e to the y cubed is constant. So let's put the constant in. Remember, when you take antiderivatives, constants go along for the ride. And now I'm going to go x to the 4th over 4. And that's going to go from 0 to square root y. I still have a dy out here like this. So I get an integral from 0 to 9. My e to the y cubed is still there. When I plug in square root y, I get x squared over 4. When I plug in 0, I get 0. So what I get is e to the y cubed. Oop, that's y squared. Y squared over 4. Yay, that's better. I'm going to pull the 1/4 out. You don't have to pull constants out. I like to do that. This is 0 to 9. I get y squared e to the y cubed dy. I'm going to do this by guess and check. I'm going to guess e to the y cubed. When I check, I get e to the y cubed times 3y squared. So I get an extra 3 I don't want. So when I fix it, my fixed guess is going to be 1/3 e to the y cubed. And that's going to be the correct antiderivative of y squared e to the y cubed. So here we go. I'm going to pull out the 1/3, so I'm going to get 1/12. I'm going to get e to the y cubed, like this. And I'm going to go from 0 to 9. So that's going to be 1/12. 9 cubed, I think, is 729. So I get e to the 729. When I plug in 0, I get e to the 0. That's 1. And we successfully completed this integral by reversing the order of integration. But remember, we don't just flip the limits of integration here. You have to chop, you have to draw the region, you have to chop the other way, you label the points at the chop, you use those labels as the inner limits of integration, and then you use the location of chops to get the outer limits of integration, and then you evaluate, just like you evaluate any algebraic expression. You start from the inside and you work your way out.